This is the quickest and simplest path that I could create to learning MCP using LangChain's LangGraph APIs. I did it in under 30 lines of code. This is the architecture we'll build to create this demo here. We'll build this architecture one block at a time, starting with MCP Server, MCP Client, MCP Tool, LLM, we'll use Qwen 0.5 billion parameters, and LLM Server, we'll use SGLang, a LangGraph agent or node that has tool calling capabilities, and finally the LangGraph app. I have a link to this notebook in the description below in my repository where you can follow along as we build out the 7 components of the architecture that we just discussed. To show how simple the MCP server and actually everything really is, I'm going to build out the entire application from Jupyter Lab. We'll start with the MCP server. The MCP server will need this MCP dependency. This is fast MCP. It's kind of the default at this point. And then it is literally 3 lines of code to build your MCP server, excluding the tools. To run the MCP server, we'll save the file and then run the file with a basic Python command. This is all the output you'll see for now. And now for the MCP client. We'll need to install this dependency, LangChain MCP adapters, and then similar to the MCP server, it is literally 3 lines of code to create the MCP client for our LangChain agent. The server and client don't really serve a purpose though without any tools. To create a tool, we go back to our MCP server code and create a function. The function has to be annotated with @MCP tools and then define the function as normal. Our example tool will take 2 numbers and return the sum back to the tool calling agent. I forgot to put the P in MCP server in my file here. I'm going to go ahead and fix that before I restart the server. I'm restarting the server since we added a tool to it. And now I'm going to rerun the MCP client code in the Jupyter Notebook. We can't have an agent without an LLM, so we'll go ahead and do that part. We first have to install this LangChain OpenAI dependency. And then we're going to use the standard chat OpenAI class here to interact and call the LLM. I'm going to use this Qwen 2.5 0.5 billion parameter model. It is tiny enough to fit on most NVIDIA GPUs, and it gets the job done. To use the LLM, we'll need some sort of LLM server. I'm going to use SGLang. Of course, we'll need to start with a dependency. And then now that we have our dependency, this is the command to start SGLang with the Qwen model that we plan to use. If you see this error, that means you need to delete your flash infer cache with this command here. And then we'll try it again. I like the message SGLang gives you when everything's ready to be used. Now we have our MCP server, MCP tool, MCP client, and an LLM and an LLM server. It's time to build our tool calling agent to be used within our LangGraph application. The next dependency we'll need is LangGraph. Now that LangGraph is installed, we need to create this LLM with tools to bind the tools to the LLM to create the tool calling node. I forgot to actually return the tools though from the MCP tool client. Now our LLM is bound to the tools from the MCP server. And now that we have our LLM with tools, or rather the LLM bound to the tools from the MCP server, we can fully define the LangGraph node to take advantage of this LLM with tools. The code is pretty straightforward, and just like most other LangGraph nodes or LangGraph agents you would define in a LangGraph application. I can't seem to stop not having typos though. It is messages state, not message state. And now it's time to finally put everything together into a single LangGraph application. I'm going to put all the imports at the top of this notebook, and then I'm going to run through all the pieces we have already completed. And then finally, to run the demo application, I'm going to do a simple inference of our agent. And then I have this detailed streaming code to help debug and see the actual stages of the agent calling the tools, running the tools, and creating the input. I took all this code and I put it in my repository here. And each of the slides shows each of the 7 components that build upon each other one by one. And then finally, at the end, I have the testing code and then the testing code with the detailed output that shows each step of the agent as it's being called. In fact, in this repository, I have every lesson starting from the very beginning, building agents from scratch all the way to this MCP server lesson as well. In addition to the simple example that I made, I decided to get a little more advanced and create this stock data and stock visualization MCP LangGraph agent. It's multimodal. It will return the pandas data frame for the prices for stocks, as well as this Plotly candlestick visualization. I thought it was pretty cool, and I thought I would share it as well. I hope you check it out. It's pretty neat. Cheers and happy coding.